Assalamualaikum warahmatullahi wabarakatuh, and a very good day to the Mr. or Miss panel. We are from Group 14, and today we will be presenting our final project 2, which is the title is Innovative Fine Aggregate for Sustainable and High Performance Concrete. My name is Nur Shazwina Adira binti Nasaruddin. My matrix number 17-23F1064.
My name is Nurul Aini Syafiqah binti Jumaat. My matrix number is 17DAS 23F1026.
My name is Nur Takifa binti Ramari. My matric number is 17-23F1040.
So the introduction is first issue of natural resource usage. The construction industry heavily relies on fine aggregates such as sand. Excessive sand mining has negative environmental impacts. Second, need for sustainable alternatives. Utilizing industrial waste and agriculture byproducts as fine aggregates. Reducing pollution and dependency on natural resources. Third, potential benefits of alternative materials. Lowers raw material cost in construction. Produces lighter and more durable concrete. Next, novelty. Our innovation introduced a triple waste fine aggregate system using palm oil clinker, roasted rice husk, and wood dust, a combination that has not been commonly studied before. We are fully replaced natural sand to evaluate the real performance to concrete using these waste materials. Through comparison, we identified which waste material gives better slump and compressive strength result. Overall, this supports a zero waste construction concept by converting industrial and agricultural waste into useful concrete products. So the problem statement. First, construction still depends on natural sand, causing resource depletion and environmental issues. Second, Malaysia produces large amounts of POC, rice husk, and wood dust which are mostly wasted. Improper disposal leads to pollution and land contamination. Last, there is a need for sustainable alternative fine aggregates in concrete. For the objective of this study, firstly, we aim to measure the workability of fresh concrete when using palm oil clinker, roasted rice husk, and wood dust as fine aggregates. Secondly, we aim to determine the compressive strength of the concrete produced with these waste materials. And lastly, we aim to compare the properties of concrete using natural sand with concrete using these alternative fine aggregates. Okay, so for significance of study, first SDG 9, where we introduce innovative construction materials using waste as fine aggregates. Second, SDG 11, by reducing natural sand usage and promoting greener construction for sustainable cities. And third, SDG 12, where we reuse industrial and agricultural waste, reducing landfill problems and supporting a circular economy.
For this project, we use a mixed ratio of 1:3 to 6, which refer to 1 part of cement, 3 part fine aggregates, and 6 part coarse aggregate. The water-cement ratio was set at 0.55 to maintain good workability of the mix. We prepare 4 sample variations based on the percentage of fine aggregate replacement, which 0%, 25%, 75%, and 100%, where 0% is the control sample using full sand, and the rest include different proportion of palm oil clinker, wood dust, or roasted rice husk. For mixed proportion control, for all mixes, we use the M20 grade concrete with a constant water-cement ratio of 0.55. The mix ratio is 1:6, which refer to 1 part cement, 3 part fine aggregate, and 6 part coarse aggregate. In this table, you can see how the fine aggregate is gradually replaced with sample material, palm oil clinker, wood dust, or roasted rice husk at 0%, 25%, 75%, and 100%. This is our mixing process. One of the main part of our project involves the testing process. The key steps we carry out include mixing the concrete according to the design ratio, preparing the sample for the cube test, conducting the comparison test to measure the strength of mix, and performing the slump test to check the workability of the concrete. For slump test comparison, this graph shows the workability of each mix based on slump value. As the percentage of replacement increases, slump values also increase, especially for roasted rice husk, which give the highest workability. This indicates that although strength decreases, the mix become easier to handle and pour. Next, the compressive strength comparison. 7 and 28 days. This graph shows the compressive strength at both 7 and 28 days. In general, all 3 materials, palm oil clinker, roasted rice husk, and wood dust, show a decrease in strength as the replacement percentage increases. Among them, roasted rice husk performed the best, maintaining higher strength at all stages, compared to the other two.
In this project, our main solution is to replace natural sand completely with 3 waste materials: palm oil clinker, roast rice husk, and wood dust. We conduct both slump test and compressive strength tests to evaluate the workability and strength of the concrete. The results show that this waste-based concrete is still suitable for non-structural applications such as partition walls, pedestrian walkways, and decorative elements. This approach offers a suitable solution by reducing sand consumption and minimizing waste disposal problem in Malaysia. Our target groups include several sectors. First, contractors and developers who can use this concrete for parts of building that don't carry heavy loads, like partition walls or walls decoration. Second, concrete product factories, which can produce lightweight blocks, small drain, or utility covers that don't require high strength. Third, landscape designer, who can apply it for curbs, walkways, garden walls, or even plant pots. Lastly, company handling industrial waste, as they can reuse POC, rice husk, and wood dust to reduce the amount of going to landfill. This project provides 3 main benefits: environmental, economic, and social. Environmentally, it reduces sand mining, helping protect rivers and nature habitats. It also decreases waste and pollution from industry. Economically, these waste materials are cheaper than natural sand, so the production cost and disposal expense are lower. And social, it helps create a safer and healthier environment while supporting local industry like palm oil and agriculture. Here are the key highlights of our study. First, it promotes sustainable materials by reusing waste such as POC, rice husk, and wood dust. Second, it offers cost saving since natural sand is expensive. Third, it provides good workability, meaning the concrete is still easy to mix and form. Fourth is lightweight, making it easier to handle and transport. And lastly, it supports green construction by reducing pollution, landfill waste, and the impact of sand mining. So in conclusion, the compressive strength of concrete decreases as we increase the content of POC, roast rice husk, and wood dust. This material absorb more water than sand, so they need more water in the mix. While this type of concrete is not suitable for structural elements like floors or beam, but it is still ideal for non-structural applications such as partition walls or decorative panels. Overall, it's cost-effective, eco-friendly, and contributes to sustainable construction practice in Malaysia. That's all from us. Thank you.